Hello everyone, I'm Candice Eve S. Mintalar. Today I'll be explaining exponential function and its examples. Exponential expression. An exponential expression is an expression of the form x plus c plus d where b less than 0, b isn't equal to 1.
Now let's have the examples. First example is we have 4 to the power of x plus 1. Second, we have 5 squared parentheses to the power of x plus 3. Third, we have 9x squared. And fourth, we have 48 over 49 to the power of x plus 1. And lastly, we have 168x. Thank you.
Next, we have exponential function. An exponential function used to calculate the exponential growth or decay given of data. An exponential function is defined by the formula fx equals bx, parenthesis b less than 0, b isn't equal to 1. Now, let's have the examples. Here is the example. Example 1. F parenthesis x equals parenthesis 1.8x. Number 2 is f parenthesis x equals 1 over 2 x. Next, we have x parenthesis x plus 2x. Next, we have fx equals parenthesis 1.9x. And lastly, we have 1 equals parenthesis 1.8x.
Sir Junji, I am Krisha Mutia, and lastly, I will be explaining simple interest and compound interest and its examples. Illustrating simple and compound interest. Simple is calculated on the principal or original amount of loan. Compound interest is calculated on the principal amount and the accumulated interest in previous period. So let's have our first example. Candice is investing 200,000 for 3 years. The interest rate is 5.4%. How much interest will Candice earn after 3 years? Here, the invested amount is the principal of the formula. 3 years is the value of t, while the 5.4% is the rate. Using the formula I equals PRT, we will have 200,000 times 5.4% times 3. So if you're going to include the percentage symbol in your calculator, this is enough. But if you don't have a percentage symbol in your calculator, you can always transform this percentage into a decimal value. You just need to move the decimal 2 places on the left. So this case, this is 0.054. By getting the value in your calculator, the answer is 32,400 pesos. So the interest Candice will get after 3 years is 32,400 pesos. The second example is find the interest and amount on 21,000 at 7 1/4% simple interest for 9 months. So here, 21,000 pesos is the principal amount. 7 1/4% or can be written as 7.25% is the value of R. 9 months is T, but it takes expressed in months, so we need it to divide into 12 because our formula I equals PRT is in terms of years. So we have 21,000 pesos times 7.25% times 9 over 12. The answer is 1,141.88 pesos. The third example is if a principal of 6,500 pesos earns interest of 192 pesos in 3 years and 3 months, what interest rate is in effect? So this time, going back to the problem, the interest is 192 pesos divided with 6,500 pesos times the value of t. This time is 3 years and 3 months, and in fraction it means 3 and 3 over 12. Using the formula, you'll be able to get this value 0.0091. I made it for decimal places because we have two significance figures here. So this rate is in decimal form. Note that 3 and 3 over 12 is just equal to 3 over 25 decimal form. And if you convert it into rate, you just need to multiply it to 100. So multiplying this into 100 will give us 0.91%. The rate is 0.91%. So the first example is compute the amount or maturity value of a note at the end of 3 years. If the principal or face value is 80,000 and the interest rate is 6% compounded semi-annually. The principal value here is 80,000 pesos, so this is 80,000 pesos times 1 plus the formula for I is I over M. Since the rate is 6%, we need to divide it by M. And here is semi-annually. So this is equal to 2. So raising this to n, which is t times m, we have 3 times m, which is 2. Note that before using your calculator, you need to choose whether 6% by pressing the percent symbol on your calculator or transforming 6% into 0.06, and this is the exponent. So you need to explore the exponent fraction of your calculator. So using your calculator, we'll get the value of 95,524.18 pesos. So the second example is, on January 23, 2017, a man borrowed 150,000 and promised to pay the principal and interest at 9% compounded annually on January 23, 2019. How much did he pay in total? Comparing to the final amount. So F is equal to principal, which is 150,000 pesos times 1 plus R over M. R here is 9% and it is compounded annually, so it's over 1 raised to t times n. So since t is 2 years, we just need to multiply into 1 because m is equal to 1. By using your calculator, the final amount now, or the total number of his payment, is 178,215 pesos.
So let's move on to the next topic, which is the logarithmic function. Logarithmic function is a function that is the inverse of an exponential function. It is typically defined with the following form: fx equals log base of x, where log base of x represents the logarithm of x with base b. X is a positive real number, since logarithms of non-positive numbers are undefined in the real number system. B is the base of the logarithm, which is a positive constant not equal to 1. These are the key properties of logarithmic functions. Number 1. Inverse relationship. The logarithmic function fx equals log base of x is the inverse of the exponential function fx equals b raised to the power of x. This means that if y equals b raised to the power of x, then x equals log base of y. Number 2. Common bases. Base 10, log 10 of x, often written simply as log of x, is called the common logarithm. Base e, log e of x, often written as in of x, is called the natural logarithm, where e equals to 2.718. Number 3. Logarithmic laws. Product rule. Log base of xy equals log base of x plus log base of y. Quotient rule. Log base of x over y equals log base of x minus log base of y. Power rule. Log base of x raised to the power of k equals k times log base of x. Change of base formula. Log base of x equals log k of x over log k of b, where k is any positive base. Logarithmic functions are useful for dealing with phenomena that scales exponentially, such as sound intensity, population growth, and pH levels in chemistry. Here are the 5 examples of real-life scenarios where logarithmic functions are used.